On this channel, we've covered a wide variety of topics involving tanks, their design, and the development that led to those designs. These can vary wildly depending on the time period they were built in, who was building them, and the doctrine that they were built to fit. Due to this diversity, it can be hard to nail down exactly what makes a tank, with everything from the armor, armament, and even whether or not it has a turret, depending entirely on the design of the vehicle and not being set in stone. However, there is one thing that all tanks share. They all use tracks. But have you ever stopped to wonder how tracks actually work? Probably not, because the answer is fairly simple, but we're going to talk about it anyways today with some help from the amazing collection here at the American Heritage Museum in Hudson, Massachusetts. But before we do that, let's take a brief tangent to talk about the history of tracks themselves.
Although the first commercial tracked vehicles wouldn't begin to appear until the turn of the 20th century, the concept dates back to around the time of the American Revolutionary War. Richard Lovell Edgeworth is said to have designed and patented a so-called cart that carried its own road in 1787, even claiming to have built and used one to transport stones. Although I unfortunately was unable to find any illustrations of that design, jumping a few decades, we find one from Sir George Cayley in the form of a patent for a universal railway. Described as a vehicle formed by two endless chains, the article details the capabilities of the design in detail, but does not appear to have been built. The first true tracked vehicle to be built appears to have come from Russia in the late 1800s. Built by Fyodor Blinov, this single-cylinder steam-powered wagon reportedly was capable of moving under its own power at a speed of up to 3 miles per hour. Across the world in the US, similar developments were taking place, with several patents issued to Henry T. Stith for his traction wheels, with the first coming in 1873. The idea would finally begin to catch on after over 100 years of development in the early 1900s, with designs such as the Lombard steam log hauler, with the first being built in November of that year, followed by their first sale to a company in Maine in 1903. This actually predates the Holt tracked tractor, which came a year later in 1904. From there, the technology would only continue to grow, with adoption across commercial and military applications. There's so much more I could include here, but that could easily make this video over an hour long, and for the purposes of this video, I want to keep this section brief. Let me know if you'd like to see more on these early designs though, as I'd love to cover them in the future.
With that brief history lesson out of the way, let's now look at how these continuous tracks actually work. In order to do this, we need to first look at the individual components which make up these. Now bear in mind, these can vary slightly depending on suspension style and other factors, but they all work the same way. The main components in these are the track links, drive sprocket, road wheels, and idler wheel. The drive sprocket, such as this one on a Sherman, as the name implies, drives the track. These are normally found on the front or rear of the vehicle, depending on where the transmission is located. On the opposite end of the track, we find the idler wheel, which helps to provide the necessary track tension to prevent the track from falling off the tank, as well as serving as the end point where the track begins its journey back to the drive sprocket. In between these two are the road wheels, which ride along the inner surface of the track and are connected to the suspension elements of the tank. Some tanks also feature return rollers above these, which help to guide the track back towards the sprocket. This brings us to the final component, the tracks themselves. Made up of either individual track links or in some cases a solid band of rubber, these are pulled along in a continuous loop by the drive sprocket. When combined together, all of these parts serve to pull the tank along whatever surface it needs to cross.
To show this in action, we can look at this animation of a Sherman's running gear and follow the journey of an individual track link. The link starts at the sprocket, where it is grabbed by the sprocket's teeth and pulled forward. Once it is past the sprocket, it continues towards the road wheels, being pushed along by the other track links between it and the sprocket. It then moves along the ground until it reaches the rear of the vehicle, where it begins its return trip to the sprocket past the idler and along the return rollers. It finally reaches the sprocket again, with the track having completed one full rotation before starting the cycle all over again and again. As you can probably guess, to move the tank backwards, this is simply reversed. This is the same for basically any vehicle which uses tracks, including everything from bulldozers to the enormous crawler transporter used by NASA.
If you'd like to see tracks like these in action for yourself, be sure to come check out the American Heritage Museum. I'll leave a link below so you can see when their next event is. I'm not exactly sure when this video will be coming out. I'll leave a link below so you can see when their next event is, or you can come and check out the vehicles for yourself anytime that they're open during the week. Huge thanks to them for letting me come and film with their amazing collection, and I hope to be back here very soon to film some more videos for you guys. Be sure to let them know I sent you.